picturesThe sequenced the genes of a variety of frogs, including the phantasmal poison frog. Rebecca Tarvin, University of Texas at Austin. View Gallery 3 image shows that some frogs are able to flush toxins through their bodies that poison wild predators without causing any harm to themselves. Scientists have pinpointed the mechanism that enables some types of frog to dodge the danger, identifying a very subtle genetic mutation that could inform the development of new drugs to treat pain and even nicotine addiction. With opioid addiction already a huge problem, scientists are on the lookout for alternative forms of pain relief, and a lot of that work focuses on the receptors that determine which signals make their way through the body. These receptor proteins live on the outside of cells and decide which molecules are allowed in, and by studying this process, researchers have uncovered potential pain relievers in the form of snail venom, green lights, and even the power of love. When it comes to poisonous frogs, medical scientists have long been intrigued by something called epibadidine. This neurotoxin binds to predators' receptors and triggers effects like hypertension, seizures, and death, while leaving the frog itself unharmed. Hundreds of experimental compounds have been developed from epibadidine, but have ultimately failed to deliver due to adverse side effects. A research team led by scientists at the University of Texas gathered tissue samples from 28 species of frog, made up of some that use epibadidine such as the phantasmal poison frog, some that use other toxins, and some that use none at all. They then sequenced a gene responsible for encoding a particular receptor, the same involved in pain and nicotine addiction in humans, and built an evolutionary tree demonstrating how the gene had evolved to shield the frog from its own toxins. The team identified a small genetic mutation, which changed just 3 of the 2,500 amino acids making up the receptor, which stops the toxin from binding to it, in effect making the frog immune to its effects. And while these frogs have developed the capability to block the toxin, the receptors otherwise work in the normal healthy way. Better understanding this process may hold invaluable lessons for scientists developing drugs that block pain and nicotine addiction without adverse side effects. Every bit of information we can gather on how these receptors are interacting with the drugs gets us a step closer to designing better drugs, said Cecilia Borges, a research associate at the University of Texas Wagner Center for Alcohol and Addiction Research and co-first author of this study. The team has published its research in the journal Science. View Gallery 3 images.